Good afternoon, everyone. I'm happy to be here again this year. I'm happy to see live faces instead of in TV boxes. Actually, we were thinking about bringing along a cardboard face of a computer screen so people could actually hold it up and recognize who everybody else was in this new culture. It's like, I only recognize you from the face up. So glad to be here today. And I love the fact that Gilman went right before us, because he sort of presented the greatest précis for what we want to talk about that I could think of, talking about the relationships between AI and data information. Well, we're going to talk about when you have geomatics, which is the real old science of creating precision mapping and measuring the earth and understanding it at that level, and then try and insert that into an information set for the world to understand things like augmented reality and information content and growth. We're going to talk about that evolution right now and where it came from and where it's going. So begin with a little bit of introduction. In my current capacity working with Maxar, a lot of my time is spent on trying to understand the implications of having a 3D capability. When I was last here, Vricon was still a separate organization that was building a 3D map of the globe at high resolution. We've now expanded that as part of Maxar into something that is going to be the underpinning of a lot of the sensing capability going forward. But with that comes a responsibility to figure out how to include other sources of information that go along with that. So I'll introduce the panel one by one and have them give a short talk about what's going on, and then we'll bring it all together. So I'd like to begin by introducing Kyle McCullough from the USC ICT in California. They work as a organization supporting the Army and the One World Terrain program, and where we've been building 3D satellite data as a source. He's been concentrating heavily on higher resolution airborne inserts, putting that in the same package to make the same kind of resolution happen. There's a lot of challenges associated with that. So I'd like, Kyle?
Yeah, thank you, Barry. I'm Kyle McCullough. I'm the Director of Modeling and Simulation at the University of Southern California Institute for Creative Technologies. We're a U.S. Army UARC, and as Barry mentioned, we do a lot of work with the One World Terrain program. A majority of our research efforts go to support the Army's synthetic training environment, but we also work with a number of other groups across the DoD, like the Office of Naval Research and ERDEC. And sort of the goal of everything that we're trying to do, and like Barry said, be able to provide these high-resolution insets, taking a multitude of source data, specifically looking at a lot of stuff we can do with SUAS and photogrammetry, but making sure that we supplement that with other data sources that are available and be able to provide that in a nice package for any of the use cases like operations and simulation and training and mission command systems. And we're currently providing the high-res insets to Maxar for the integration into the One World Terrain Foundation as well.
Thank you, Kyle. So that, between the two of us, represents the end pieces of truly geospatial information, pure location, time, that kind of setup. But to be useful in any context, especially the military operator's role, there's a lot more types of things involved. And Jackie Barr, Bay Area White Space, comes here with a long, deep background in understanding things that have been called over the years SOM and ABI, and there's been a series of acronyms just sort of explaining how do you take information and make sense out of it in context. So Jackie, please.
Yes, absolutely. Thank you, Barry. So my background and what I'm here to represent on this esteemed panel is the perspective of the analyst. So looking at the entire intelligence value chain from the perspective of that person who sits at the end of it or close to the end of it, and whose job it is to bring together all of these pieces of information in a way that is as accurate and reliable as possible in the face of many unknowns. So spatial data is an incredibly powerful tool and resource, and spatial referencing, incredibly powerful tool and resource for analysts as they do that job. I've loved the conversation today about going beyond imagery, non-pixel GEOINT. And Gilman Louie talked about the important features and the universal features of X, Y, Z, and T. I'd add one more to that, which is R, relationships. That's the job of the sense maker, whether it's human or machine or a combination thereof, to find linkages in and across that information that's been properly referenced and pass that on to decision makers supporting human security missions. Thank you, Barry.
Thank you, Jackie. So having said that, we've got now several sources of information that need to be put in the hands of the exploiter, the user, the operator, depending on your use case you're talking about. And one of the most interesting cases to look at in the very individualized realm on that is what happens when the data is not only literally in your face, but on your face. An augmented reality system network that actually allows you to exploit and see more of the information. And so we have Dimitrios Dozer from Microsoft here today, who works as one of the leads for the IVAS program, which is trying to solve exactly that problem. So I'm interested if you'd like to share.
Yep. Hello, everyone. I am Dimitrios Dozer. I am a senior program manager in Microsoft's mixed reality government sector. My project is particularly the IVAS program, the Integrated Visual Augmentation System, which we do exactly what Barry described. We take all the different combat inputs that come in, whether it's your friendly forces location, your hostile forces location, hazards, things you need to avoid, terrain, mission planning, and we put that in their face. And it's it's funny to hear it that way, but that is where we are right now. How do we take things from down here to here? It's a limited environment that we get to work in, and we have challenges like the previous speaker mentioned. Like, how do you get the connectivity to get the data to put it, to display something relevant real time to the operator? What do you do when that's denied to you? How do you deal with limited information and bandwidth coming in? How do you control things when you're not using your hands and you have, a medium like your eyeballs to be able to control stuff? So that's it's a rapidly growing sector commercially, and militarily, it's something that we're trying to mature just as rapidly. So I look forward to this panel, look forward to this conference, and what we do here as far as GEO is one of our primary missions in mixed reality. It's something that it's common to everyone. Every soldier on the battlefield wants to know where they are, and being able to display that along with what's going on around them, what they should be aware of, is something that we're striving to do better with mixed reality.
Thank you. So that's the information and on person one case of what's going on. Traditional mapping and everything that goes along with it was much more about being able to have a common information understanding for everybody. Everyone has the same. If you came from LA and you've ever had a Thomas guide, big map book with all the information on what's going on, that has been supplanted in the current generation by capabilities in GIS structures, where it's information sources many to an individual screen analyst working. And Richard Cook from Esri comes here as they're trying to evolve the disciplines continuously and understand how to better convey information. And so we're looking at how does that all fit together too. So Richard, please.
Thanks, Barry. Richard Cook, I'm a Director of Business Development for Esri. My background, though, is primarily in imagery and remote sensing. Actually, if you go back even further, I started my career on the F-16 program doing work on the simulator, the F-16 simulator. I graduated from there to a computer graphics company that was working on a 3D rendering for first-person shooter games. And to our previous speaker, he made the comment, latency kills. Well, literally in those games it did. If you had any latency whatsoever, your character was out of the game. And so it was amazing how much time and energy we spent on making sure we hit 60 frames per second in a video game. And I think I reached the point in my career where I said, there's got to be more than helping some teenager sit in his parents' basement playing video games. This technology's got to have some greater common good. Circuitously, I found my way to Esri through a relationship I had with founder Jack Dangermond. And if you think about and most of you know Esri. I mean, I probably don't need to tell you who Esri is. But if you think about how we look at the world and how we look at this evolving area of moving from 2D maps to 3D maps, and we think of it in really kind of three critical components. Actually, I'll go back to the speaker this morning. He said something that I just love. I wrote it down, and I'm going to steal it. GEOINT is the intersection of maps and data. And I think that's really how we view it at Esri. And our mission in life, and Jack says this in every public interview he gives and every presentation, our job is to build a platform and tools to help all of these folks do their jobs better, do their work better. And it really comes down to kind of three pieces. It's that authoritative foundation data that you mentioned, Barry. I mean, Esri is extremely dedicated and diligent about helping you create your authoritative foundational data. But then that next system is that system of insight, being able to do the necessary analysis and information extraction from that data. And then the system of insight, making sure that every key stakeholder has the access that they need to that information. And so underpinning all of that is just our commitment to help Jackie's organization and her customers do their jobs better, and likewise with my colleagues to the left.
Fantastic. I want to pull on a thread a little bit before getting too deep into some of the things we discussed previously. You were talking about relationships, Jackie, and my mind started spinning with the various types of relationships one could consider. And we're going to talk a little bit about information overload, but first, give us some idea which types of relationships are the most necessary to prioritize, and how do you go about thinking about that problem?
Absolutely. So let's start at the data layer, right? So you have a foundational region, area of responsibility that an issue that you're looking at as an analyst is related to. And then you have access, hopefully, to lots of other sources of information that then you want to be able to reference to that foundation at a certain point in time. This is all pretty straightforward, right? That's one class of relationship. It's that correlation, that link between the data point and its geospatial context. There may be no imagery related to that endeavor whatsoever at this point, but any remote sensing data or human-generated data can be referenced in that way. Then you apply a temporal filter to sort of further strengthen your understanding of that relationship. So there's like the data layer relationships that can happen. I don't want to discount also semantic relationships that can be discerned at the data layer. Now, computers are pretty quite good at helping us out on that level, right? Pre-correlating information for the user. But as Gilman pointed out, doing these types of spatiotemporal computations at scale are incredibly intensive and almost untenable if you stick to sort of a traditional CPU-based approach. So there's a lot of innovation that's occurring in that space, and we've been involved in that over the last year. It's been quite fruitful. The next sort of layer of relationships you can look at human scale. So the sense-making piece. Are you looking to understand things associated to organizations, or things associated to people, or people associated to people? And depending on the types of networks or issues that you're looking at, those relationships can vary. It's that top layer where I think as augmentative technologies come into play, whether it's AI or augmented reality, mixed reality platforms, the analyst is going to be increasingly inundated. So our problem used to be big data. How do we process it? Now we're getting much better at processing it at scale. And now those predictions and outcomes are going to crush that poor sense maker downstream of them. So I think it's a really interesting problem. And the number of relationships you could try to extract are only limited by your imagination or your problem set, Barry.
Okay, thank you. Pulling on that thread from the other side, Kyle, you, in some senses, working the high-resolution thread of only the imagery side of things, have the benefit of seeing things very clearly, but only the spatial context and nothing else to it. What do you think that brings to the table in terms of what I'm going to get to? I'm hinting ahead next is choosing which information needs to be conveyed, but which are the critical parts you would bring forward in a relationship like that?
Sure. So I guess, when you're looking at the high-resolution 3D data that you can get from something like a drone collect, there's a lot of value to that, like the currency of the data. You can get it immediately. Being able to get the quality and the resolution of the data, being able to get centimeter and in some cases sub-centimeter data. A lot of that works really well in a non-tactical environment where you don't necessarily need to worry about the sound of the buzzing of the UAS as it's collecting the pictures. And so when you have that as sort of a grounding point for data that's going to go into something like the synthetic training environment, you at least have a place to start where you can begin to make smart data. So when you look at the way that Maxar, for instance, has the foundational data, and they've got an excellent pipeline for the machine learning processes for doing land use lane cover and semantic classification. And so we do a lot of that on the high-res side as well. And so being able to, again, that idea of the big data problem sort of we've taken care of that. So now I like to reframe it as like it's a big data blessing is what we're currently dealing with. And so being able to take that high-res data and be able to semantically understand it and break it apart into the component pieces and being able to understand the material classification of a building and where the windows and doors are and all of these things that you can't necessarily get from some of that foundation data because it was taken from an aircraft that flew too high or it was off angle or it came from a satellite, and being able to have some more information that again can kind of be fused into this larger data set that can ultimately be authoritative. And so that's one of the challenges Barry and I and the ICT and Maxar teams have been facing for a while is, how do we take that high-res 3D imagery and fuse that in a way that is going to actually be both performative within the greater context of the foundational database, but also ensure that that data is going to be geospatially accurate, because for anyone who's done any drone collection or photogrammetry, you might have seen like it's pretty tough to get a good absolute accuracy on some of the drone collects, even when using stuff like real-time kinematic. And that's a big part of where the relationship with Maxar has played in, specifically using things like their P3DR pipeline to be able to spatially align data that might not be accurate enough for some of these use cases.
Excellent. Richard, okay, now we've got non-textual, non-contextual spatial data. We've got information and relationships and things like that. And now, in the GIS world, this needs to be put into something that for the desktop user and the users working that way has to be intuitive and ready to convey. And what steps need to happen to make something like that successful in the process? What does Esri have to do to make that information come together in a way that actually makes it intuitive and usable?
Well, I think we have to integrate with some of the work that that you guys are doing on the One World Terrain program. We've partnered with both Epic and Unity to figure out how to integrate our technologies and the outputs of our technology into these immersive environments. And we're also investing quite a bit of R&D in terms of how do we bring AR, VR natively into the ArcGIS environment. So we're working hard to make sure that we're providing the tools and the platform that's supportive of these technologies, so that when this data is available and it's available at scale, we're ready for it. We can handle the volume and the veracity of the data.
Outstanding. So then, when you put it in microcosm, Demetrius, it shows up in a headset. And I'm about to get to the panic side of that first, but anything you would like to say about that evolution from the data we've been saying before we get into the hard part?
Yeah, so once you get it all to us, it's the challenge of filtering out what's necessary, filtering out what's appropriate, what's relevant, getting to the point where we're not a cognitive burden on the user with data, or a burden on the network. So we're still operating within systems that weren't designed to have this much data presented to that low of a level. So we're talking, the warfighter close combat force level. Before, some of these guys may not even had radios, and now we're trying to take all the data that we bring in, push it over legacy pipes, make sure it's available to those that need to use it, and that's a huge challenge. And some of the ways we try to solve that just through looking at it from the perspective of the warfighter. So the soldier-centered design or warfighter-centered design, what information do I need to make my job, to do my job on the edge? Some of that we've been able to distill just through more AI, better processing on the edge. So one of the components of our system is, processors and GPUs at the edge, but that can still only do so much. We still have that cost, which is the network, the batteries, just your field of view. We can only display but so much data. So everything that we bring in does come at a cost, and just balancing that and filtering that is a challenge.
So, keeping the idea of challenges, when we were preparing for this panel, we talked a little bit about groups that experience data differently. two examples that came to mind are one that has sort of a different way of processing spatial information. There's a condition you can have called synesthesia, which causes you to sort of experience numbers as colors or sounds as smells. And the cross-wiring is interesting, but it actually creates some capability for folks who have it, in that a color number synesthete can look at a page of nines. I'm sure you've all seen this in like little magazine intelligence tests. It's a page full of nines or M's, and you have to find the 6 or the W, the only one that's in the page. People who have this condition see it innately. It just doesn't look the same to them. And so we were talking about the idea of possibly using some of the sense information that's coming in as a visual image and sending it someplace else. An auditory cue, a haptic cue. And I'm just going to throw this out to any of you who want to pick it up and see what might come out of something like that.
So I'll jump in
Please.
quickly. So we were talking backstage, and I think it's come up several times during this conference and prior conferences, that humans are incredible pattern recognition machines. Our wetware, the gray matter, is really well adapted to performing those types of tasks, almost regardless of the input. And so when you exploit the multiple channels you can sort of think of, or the multiple sensory inputs that we have as individuals, auditory, tactile, visual, and others, you create an opportunity to almost simulate synesthesia-like instincts about, oh, that sound and that visual, when I see those two things together, I know I need to act. So I'll give you an everyday example that has almost nothing to do with GEOINT. But I'm a mother of 3 kids. When I hear a thud come from a location in my home at a time of day when it shouldn't happen, I know I should probably go, especially if it's not followed up with a scream from one of my kids. I know something's gone very wrong. So that's the type of thing I'm talking about. It's a little bit of a trite example, but we do this kind of processing all the time, every day. And it happens almost at a subconscious level, which means 2 things. 1, it's incredibly fast. And 2, it's very subject to bias. But I think that mixed reality, augmented reality technologies really have present an opportunity to exploit the benefits of these approaches.
So, anybody else want to comment on that?
Yeah, I think that's interesting. Our brains are amazing things, but they're also transactional. If you think about that model you just described, it's an instantaneous transactional read, write, search of the database, and decision made.
Right.
And I think if you think about what we're talking about here, getting to that immersive reality with foundational data, the end game has to be a transactional system. These, for now, if we think about the video game example I used earlier, I mean, that's record and playback, right? You have an authoritative data set, it's recorded, it's played back. You may have different decision tree permutations that can come out of that, but they're predetermined. And I think this gets to what our previous speaker was talking about. It's being able to take what we do in our brains and make our systems transactional at that level to eliminate the latency in the system.
So one more piece on this, and I'm going to go over the open questions. I got some good questions here. But the other condition we were talking about in our conversations before were people living on the autism spectrum. People all over the levels of understanding of things, but they have a specific issue with responding quickly to inputs. When too many things come at them at once, they have to dial it back. And Demetrius, you were talking about cognitive loading. I think we're creating a situation of an artificially autistic situation if all this is coming in too fast. So what do you think the prescription is for how do you do the dial back once you've already decided what's important, and now the operator has to decide it's still too much? How do I pull back from that level?
Yeah, so some of it is just trusting the sensors and the inputs that are coming in and taking that data and distilling it down into an action. So like, do I need to avoid this area? Do I need to seek cover? So it's taking all those inputs, trusting them enough to be able to derive an action from them. And again, I love the video game example, like huge Call of Duty player, love a good night of Call of Duty. And shots fired, enemies over here, I get a halo effect over here showing me that, hey, something's coming from over there. I have to trust every single input that is telling me that something is over here, and all I know is something is over there. I don't know anything else but that, and that's all I can trust. And that's what you have to distill some of these sensor inputs down to. I can't, at the time, I don't need to know where it came from, how it was collected, do we trust the source of collection? I just need to know that something was over here. I need to do something if I want to stay alive.
Excellent. So I've got some questions here, and actually one is not named, but it's clearly targeted to Jackie, because it says you were talking about geospatial X, Y, and Z, and you added R for relationships. Quoting, however, relationships can only get us so far. Should it instead be X, Y, Z, R, and T for true friends?
That's an interesting question. I think until we get past R, we don't know what's past R. There, of course, are patterns in aggregate that once we understand R, that will emerge, right? And so, like Gilman was talking about, these flows of information. We're not even at the point yet where we've got the transactional view, right, across the board. I'll give you an example. One of the projects that I'm most proud of that we've been involved in as a company over the last year is understanding human behavior through the lens of really precise, accurate mobile device geolocation data. And we looked at it for public health purposes. And what we were trying to measure was the probability that two people were within 6 feet of each other for a period of 5 minutes or more outside of their home. Does that sound familiar to anyone in the audience? Right, the conditions that we've been trying to sort of avoid for the last year plus. And in that project, we started at this micro level of what is the relationship potential in a pairwise sense between two individuals. But what we found was that when we can aggregate those probabilities together spatially or geospatially by region, now we're seeing trends and patterns over time in a way that we never could before. And lo and behold, those metrics and the spatial heterogeneity and the temporal heterogeneity in those measurements actually turned out to be a very good predictor of future cases in a situation where we had no other leading indicators. So this is what I'm talking about, the power of relationships. Until we get to the point where we're acknowledging them, we can't measure them at a scale that's actionable and that we can trust. And I think, Kyle, I think about the accuracy of the geospatial information that we're registering that to, or that we're using to contextualize it, and that becomes critically important as well as these insights become more and more sort of micro-local and micro-temporal.
Yep. Just a quick addition, I think the next letter, I think you said it twice, I think it's P. So I think if you have enough X, Y, Z, T, R information, then prediction and probability is sort of the next logical step. Because if you have enough data defining that single space in time as T, with everything preceding it, then all of the predictions and the models that start to actually provide that actionable data of what's next, can sort of be realized. So I'll add P to the end of the list of letters.
We'll have a nice alphabet when we're all done with this process, the new GEOINT alphabet. I'm going to throw this both to Richard and to Demetrius, because they're asking actually, does the GEOINT community have the data and metadata standards usable in such a way to incorporate any of this information? And if not, what's the path to get there?
Oh, wow. I love this one. I think that we have to start with the standards that are there. There are a number of systems that we as for example, augmented reality experience, we're not gonna just immediately come in and create new systems. So we have to fall into the systems that are there, fall into the standards that are there, build the trust before we can go in and start making new systems, new standards, that sort of thing. A time will come when we do need to define how we interact with objects in mixed reality or virtual reality and develop new standards around it. But right now, I don't think is that time. It's gain the trust of the community, fall in on what's there, and mature.
yeah, the standards are not there yet. They're not where they need to be. But I'm sort of of the same mind that it's okay for now. I don't think it's okay for much longer, but it's okay for now. It's similar to the question that was asked, actually, I think Tara read this question for our last speaker. Is there a common ontology or taxonomy for AI? And the answer to that is no, but it's okay. And I think where we are in the geospatial part of this business, I think that's okay now. I think it's become a little too politicized, quite frankly. I think we need to depoliticize it a little bit, and we've got some work to do there. But I think for now, it's okay.
Okay. So we're just about out of time, so I'm going to throw a lightning round at all of you. It's an easy question to work from, but you could probably spend a half an hour answering, and I'm going to ask for more like 30 or 45 seconds. What are you excited about for the future? Jackie?
I'm really excited for the exploration of how to augment and amplify human cognition through the use of all of the technologies we've talked about up here today, and tackling this problem of harnessing the increasing abstraction of data with geospatial data in an embodied sort of interface. And I think that's going to be a huge challenge that might span far beyond my career, or maybe my kids. But I think it's a really exciting time with a lot of opportunity. And we have a lot to learn from the communities we discussed today as well, possibly.
Yeah, so I guess one of the panelists this morning made the comment that for GEOINT tradecraft going forward, or for any use case of imagery and remote sensing, it's typically 10 to 15 elements of data that are not imagery combined with imagery to get to the solution of the problem. And I think Jackie actually hit on it very early in this panel. It's relationships. It's relationships expressed, enriched by space and time, expressed in space and time, and then I think it's symbiotic as well. I think space and time tells us about the relationship, and then the relationship reinforms space and time. To me, that and this is a problem we're working on at Esri, and so you asked me what's most exciting. That's really, I'm the imagery guy, right? That really is exciting to me.
I think the most exciting thing for me right now is that blend of the real world and what we can do in augmented reality in the respects to training. So taking some of the stuff that we can do in a synthetic training environment and turning this room into a real time and space situation where we could rehearse contingencies, where we could engage enemy forces, where we could simulate enemy force activity, but just being able to do that in a number of locales, different places, and just run through and rehearse those things in augmented reality. And that's something that we're solving right now, initially indoors, but that could easily be, well, not easily, but it can be expanded to incorporate the outdoors in just a variety of different places. So I think that intersection of mixed reality and the real world and training is what I'm most excited about.
For me, it's definitely the metaverse. So that is what I'm most excited about. I won't get too much into it because I'm going to be part of a great panel on Thursday at 3 p.m. discussing the metaverse in more detail. But yeah, that to me is where we can take all of this and apply it in a very unique way that sort of builds the future of what we think about for geospatial data and interconnectivity and access. And it's there's going to be a lot to come. All these tools will get put to a brand new use. So.
Yeah, I'll finish with my own comments. The whole realm across the board of what we've heard today of the experiential relationships with data and bringing more information the right way to users down the line, and being able finally to get back in the realm of being able to exploit that, understand that in person as opposed to just in the little tiny boxes. How does that play out in our future world is what I'm most excited to anticipate and look forward to over the next couple of years. And I believe that does run us out of time, so I'd like to thank you all for listening this afternoon, and hope you enjoy the rest of the conference.